All right, ladies and gentlemen, I'd like to get started. My name is Jun Nogami. I'm the chair of the Material Science and Engineering Department, and I would like to welcome all of you to back to the Weingard Lecture Series, an annual lecture series that we have in our department. Today is actually the second of two Weingard lectures that we've had by Michael Ashby. But before we get started, I would like to introduce to you Bill Weingard. So William C. Weingard served in World War II. At the time, he was the youngest officer in the history of the Canadian Navy. Is that still true? He was a navigator. Okay. After the war, he enrolled at U of T in metallurgy, and he graduated in 4T9. He got his master's in our department in 1950 and his PhD in 1952. So all the graduate students in the audience can do the subtraction and make a note of that. After that, he taught in our department until 1967 as a faculty member. Then he went on to bigger, I'm not going to say better things, but he became president and vice chancellor of the University of Guelph. And then he was elected to Parliament in 1984 in the riding of Guelph, and then re-elected in 1988. During that time, he served as Minister of State, Science and Technology, and Minister of Science under the government of Brian Mulroney. One of my favorite things about this lecture series is to see you back in our department for however brief a time every year. Ladies and gentlemen, Bill Weingard.
If I don't use the mic? No. Yes. Who said no?
I think the videographer would like you to use it.
All right, okay, I quit. I'm not going to say very much, but just how did this come about? Back in 1950, when I first became a graduate student in this department, Lloyd Pigeon was chair, and Bruce Chalmers was the physical metallurgist. And we had unbelievable experiences. They brought in to talk, and to talk with us, top-notch people in the world. You won't recognize, C.S. Barrett was Mr. Crystallography. And we had people from GE Labs everywhere. And what a great idea, because they actually took the time and talked to us. Like, I'm sitting right across the desk is C.S. Barrett. Wow. And so I thought, if I ever have the money, I would like to do this for the current department at U of T. Because I know universities have no money, but they do have lots of people. So we met and decided that this wouldn't be a bad way to introduce some really top-notch people of the world to talk to metallurgy at U of T. That's the reason for it, and we have been very, very successful in terms of stirring up interest in that kind of process, not only here, but in other universities as well. So I'm glad to see you all here, and I look forward to Mike Ashby as you do. Mike and I knew each other from pub life in Cambridge many years ago. So thank you.
So I see a few new faces in the audience, so I would like to reintroduce our speaker. Michael Ashby is the Royal Society Research Professor Emeritus of Material Science and Engineering and the Principal Investigator of the Engineering Design Center at Cambridge University. He is the co-founder and chairman of Granta, a company that publishes the CES material selection software that we use in our department and is used both for the teaching and the practice of material science and engineering in universities and industries worldwide. Dr. Ashby received his PhD from Cambridge University in 1961. Among his numerous honors and awards, he is most notably a Fellow of the Royal Academy of Engineering, a Fellow of the Royal Society, and a Commander of the Most Excellent Order of the British Empire. Ladies and gentlemen, Michael Ashby.
Thank you very much for that introduction and for your words too, Bill. Bill has had a formative influence on, either directly or indirectly, on many people in this room, I'm sure, perhaps almost all of you in one way or another, and he has done so for me too. I was lucky enough to be a graduate student at Cambridge at the time that Bill visited, and that was one of the most enjoyable and informative years of my life. It was thanks to Bill. So thank you very much for that. Now, my title is that, and the background is this. Many departments of materials engineering, our own included, say very little about industrial design. We spend 4 years teaching our students about engineering design and the role of materials in it, that kind of thing, but not much, if anything, about industrial design. Well, does that matter? That's a question I'd like to see if we can answer. There's a car, sorry, and there is another car. They both have 4 wheels, they both have an engine about the same size, about the same power, they even cost almost the same. But there the resemblance stops. This one will transport you in cushioned comfort, quiet cushioned comfort. Well, this one has many qualities, but quiet cushioned comfort is not among them. It's an extremely noisy little car. And yet they coexist. Well, why do they coexist? Because some people prefer one and other people prefer the other. So let's rephrase the question. How do you design products that people prefer? Well, a product has a cost, and that's the cost to the manufacturer for the materials and the labor and the design and all the things that go with making it. It has a price, which is the price at which is offered to the consumer. And it has a value, and the value is what the consumer thinks it's worth. And this little inequality kind of sums up one essential of a successful product, which is the cost is less than the price and the price is less than the value. And phrases like, it's not worth the price, mean that P is less than C, the price is, the value is less than P. You've got one of the inequalities wrong. And saying saying something is good value for money is saying V is much bigger than P. You think the value is a great deal more than the price. Right, so let's see where we can go from there. There are 2 pens. They're my pens, and they cost me about $10 each. Here are 2 more pens made by the same company, and they retail at around $3,000. So you might ask, does this one write, 300 times better than that one? And that seems a bit unlikely because my pens write perfectly well. So how is it that these 2 products coexist? What is it about them that allows somebody to want to pay that much money for a pen that writes no better than one that costs only 1/30th as much? Well, let's look at what determines cost. That's the technical design and the materials and the process and the labor, as we said a minute ago. What determines price? It's the cost plus some kind of margin so that the manufacturer and the retailer make a bit of money. What determines value? Well, the technical design certainly matters. If the product doesn't work, people are not going to value it. But there is also the aspect of it which goes under the heading of industrial design. And there are 3 words which I'm going to associate with that: aesthetics, associations, and perceptions. And those are 3 words you're going to hear several times in this talk. I'm not going to define them yet, but I will later. Right, why does industrial design matter? Well, today, product maturity and market saturation means that the marketplace is crowded. There isn't just one car in a given a given price range and power and so on. There's hundreds. So industrial design allows differentiation. It allows makers to tune their products to a particular consumer group. So here's an example. There are 32 of the 78 kettles that are offered, jug kettles, electric kettles, that are offered by a retailer in Britain. And as you can see, they all have the same sort of size. Indeed, they are all about 1.5 liter kettles, and they all are about 2 kilowatts in power. So technically, there's nothing to choose between them. And yet they all coexist. And that's because the manufacturers of these things have tried to fine-tune them, aim them at a particular consumer group. Well, here's another reason that industrial design matters. It creates corporate image, which is why airlines dress their air hostesses and other staff up in uniforms and things like that. It's to create a corporate image. Well, industrial designers seek to create a corporate image using industrial design with their products. And the industrial design thereby creates brand loyalty, if you're lucky. If people begin to like your product, they will recognize it, even if it's a new model, because it has got a kind of a DNA that it carries with it, which has to do with the technical and industrial design. And here are some examples. I don't think I need to tell you who makes each one of those three things, because the industrial design that has gone into it is so characteristic that even if you hadn't seen that particular model before, you'd know exactly what it was, who had made it. Here's a third reason, and perhaps the most important of all, the environment in the broadest sense. Products are part of our environment. We live with them. They're in our house, they're in our bedroom, they're all around us. If they're pleasing, if they bring satisfaction, then they have enhanced the quality of your life. If they're displeasing, if they irritate you, then they've done the opposite. They have diminished the quality of life. So industrial design has many dimensions, and those are three. I used the word DNA a moment ago, and really the integration of all these has to do with the DNA of the product, and that's what industrial designers try to create. Well, there's an example of a bit of interior design which is got the materials, the colors, the textures have all been chosen to try to create a certain kind of environment. Well, let's now look at product design. What are the components of product design? First of all, functionality. The product has to work. It has to be safe, and it has to be economical. We teach our students all about that kind of thing. Secondly, usability. The product must be easy to use and understandable. That's not true of all products. Some manufacturers don't get that right. Some designers, I mean, don't get that right. And then finally, it's got to give satisfaction. Well, these two parts of the product design process are sometimes separated, so that the bottom half is called technical design and the top half is called industrial design. These days, the thinking about design is not like that. It's seen rather, oh, I've lost one there. It's seen as an integrated process. That's to say, the product is designed with simultaneously thinking about satisfaction, usability, and functionality. And that is a much better way to think about it. And indeed, it's one of the reasons that students of mechanical engineering and of design should know about the top end of this pyramid, the satisfaction bit. Well, the bottom bit here is familiar. Those are the things that we teach our students. The top bit is less familiar. It's unfamiliar territory to many. And that's the bit that involves these words that I've used once already: aesthetics, associations, and perceptions. So I'll come back to those in just a minute. Well, let's look at product design. The first thing you have to think about is the context. Who are you designing this for? What's it going to do when you've made it? Where is it going to be used? When and why? So those 5 W's are the questions we want to address first, and here they are. Who, what, where, when, and why. Any industrial design course starts with those words, incidentally. The first thing students are asked to think about is the context. So who? Is it for men? Is it for women? Is it for sportsmen? Is it for children or elderly people or disabled people? Well, each of those has a different set of needs and a different set of values and things that bring them satisfaction. So you have to know who you're designing for. What? Well, that's largely to do with functionality. Where? Is it going to be used in the home, in the office? Is it an industrial strength product? Is it one that has to survive a high humidity in Africa or something like that? Where is it going to be used? And when? Day, night, occasionally, all the time? Oops, sorry. And then finally, why? Why do you think people would want to buy the product? Is it to fill a basic need, like a car perhaps, or is it to meet an aspiration? Well, the cars that I showed you on the front cover, the one on the left probably was to meet a need. If you've got a family, you've got to move it around. But the one on the right, the Morgan, is a car that people largely buy to meet an aspiration rather than simply for transport. Well, the answer to these questions sets what's called the mood. It sets a context. It doesn't design the product, but it does condition the decisions that are subsequently made. Well, let's now look at the next bit of this. We now have to create the product itself. We've got a mood, we've got a context, and if we're going to make something tangible, we need materials, metals, ceramics, polymers, and composites, and we need processes to shape, to manufacture the product, to shape it and join the bits and surface treat it and all the rest of it. So these two sides, which we're familiar with as material scientists, create what I would call the product physiology. It's the bit that you can touch. It's the sort of the body of the thing, the bones and the flesh of the thing. But there is another side to the product. First of all, there's the usability, and that has to do with biometrics and biomechanics, the size and shape that you are, the weight you are, the forces that you can exert, the messages you can interpret if the product has to tell you that it's doing something, that sort of thing. And finally, there is what I'll call personality up there, which has to do, again, with these three words I've been using all the time. And that side, you might call the product psychology, the part of the product that is not tangible exactly, but it conveys itself to you nonetheless. It's there. So the character of the product is the sum of all of that. Notice that materials and processes play quite an important role in this. It's the choice of material. It interacts through here with personality and with usability and all that kind of thing. Well, I'm going to go back to my pyramid now. Here it is. And just expand on it a little bit. So the bottom slice of the pyramid, we said the product must work, be safe and economical, and that's exactly what we teach our students all about. It requires sound technical design, proper choice of materials, and proper choice of manufacturing processes. And there are plenty of tools now to help with this, computer-based tools, numerically controlled machinery for manufacture, and so forth. The next step up, products must be easy to use and understand. That means that if you ask it to do something, you switch on, for instance, it has to send you a signal saying, I've understood that, and I'm going to turn myself on, that sort of thing. Otherwise, you go on prodding the button because it isn't responding. Well, that kind of thing is now well understood. In fact, the understanding of what's called ergonomics, that's the design for usability, derives from World War II, roughly, when pilots were finding it increasingly difficult to cope with difficult environment in a cockpit with a great number of controls. And out of that emerged a whole science of how to design things which are usable. That seems to have been lost on the manufacture of DVD recorders and things of that sort, since you can, unless I turn the lights right up, I can't even find the buttons, let alone know what to do with them. Now, finally, that has to do, as I said, with biometrics, how big you are, how fat your fingers are, interaction with the mind, intelligibility, and also interaction with the environment that you're in. If the product emits a lot of heat or smells or does other unpleasant things, then it diminishes the usability. There are now standards for all of these things, and products, if they're going to be legal, have to meet some of these standards. So this is now being built into standard engineering design as a requirement. Now, the difficult one is this one. The product must be life-enhancing and rewarding. And that has to do with these words again, so we better say what they are. Aesthetics. Well, anesthetics dull the senses. That's why you take them, so you don't feel something. Aesthetics, I'm going to use in the sense of the opposite of that. They're something that appeal or stimulate the senses. And the senses, we've got 5 of them, are sight and hearing and feel and taste and smell. Associations. What does it remind you of? What does it suggest? I'll show you some examples of that in a minute. And then finally, perceptions. They're different from associations. Perceptions are, what's your reaction? How does it make you feel? So something might have an association which everyone would agree on. I'll show you some in a minute. But they might feel quite different about them. So perceptions and associations are not the same thing. Now we're going to look at these 3 things in a little bit more detail and see how they are achieved. So there they are again, product personality with those 3 things. The first one was aesthetics, and there are the 5 senses again. Well, the 5 senses sense things that are real. You can touch them or feel them or something like that, and they're made of materials, so surely there must be a materials background to these, something we can actually analyze. And indeed, in some cases there is. So let's look at how you can model, let's say, these things here. Well, sight. If something is transparent or clear or opaque, that's easy to measure. And I won't even go into how you do it, because you just shine a beam of light through and see what comes out the other side. Matte and reflective, there are ways of measuring the reflectivity of things, of materials and surfaces, and that's perfectly standard too. So there's nothing complicated there. Here are 2 that are a little bit more complicated. Many product reviews talk about the product as being warm. Well, sometimes they mean visually warm, that the colors are warm. Sometimes they mean the feel of it is warm or cold. And similarly, soft and hard. And they're not as obvious as they look. Here's a finger. Put it on here. First of all, the surface deflects, and that's something to do with what your sense of whether it's hard or soft. Heat is also conducted out of it. Your body's one temperature, and this is, we'll say, at room temperature, which is at a lower temperature. Heat is conducted out, and that, if it's conducted out quickly, it feels cold, and if it's not conducted out fast at all, it feels warm. Right, let's see if we can model that. You can. It isn't simply the thermal conductivity. It's because the heat leaves your finger, enters the solid here. If the solid has a high specific heat, it takes a great deal of heat to warm it up, and that means it sucks a great deal of heat out of your finger, and it feels cold. So it's a combination of density, thermal conductivity, and specific heat. And that little thing there is simply a model of how fast heat drains out of a hot spot if you put it on a cold surface. Soft and hard is a little bit more subjective. Something soft gives way when you press it, like a piece of sponge or a piece of rubber. And that has to do with the modulus. But the finger doesn't feel things as soft once the modulus rises to a certain level, because no matter what the modulus is above that level, your finger hasn't got enough force behind it, or you can't exert enough pressure to make any kind of indentation. And then your sense of hardness comes about from something else, that you can scratch it or something of that sort, or one thing scratches another. And a measure is an arbitrary one, is to combine these 2 like that, just take the square root of the modulus and the hardness, and say, well, we'll call that our parameter for soft and hard. Now, I'm doing these 2 things for a reason, and there's some more to come. It's because there's a group in London that has been studying what they call the sensuous properties of materials. I don't like that term, but nonetheless, that's what they call it. And they've been doing, when they have some parameters available to make the comparison, they do blind tests. They get people to come in and say, put on a blindfold and tell me if that's soft or hard, or warm or cold, that kind of thing. And it has to do, underlying this research is contributions to product design. So it's not just silly stuff. They are trying to measure things. Right, so let's plot those two quantities. We can form that quantity, we can form that quantity, and we can plot them, and there they are. Here is warm to cold. So that's that parameter with thermal conductivity in it. And here is soft to hard, and that's that thing with modulus and hardness in it. And here's a sort of the materials spread out here. Metals are up here, ceramics are here, dense ceramics are up here, porous ceramics are down here. Here are polymers, here are elastomers. They have a lower modulus, as we know. And down here are foams, like polymer foams and that kind of thing. So these are the squashy, warm things down here, and these are the cold, hard things up there. Well, the question is, if you now do blind tests, you know where you'd like things to end up. If you can ask people to rank them, you can at least put the ranking on this picture and see if it works. And it does. It works remarkably well. Not a great surprise, really, but it's quite interesting that blind tests of that sort do correlate with something that you can attach to a set of material properties. Right, let's try some more. Acoustic properties. That's rather fairly easy. Acoustic pitch has to do with modulus and density. If you make something with a high modulus and a low density, then it vibrates at a high frequency, and vice versa. Acoustic brightness has to do with some kind of absorption, like the damping coefficient, the mechanical damping coefficient. In fact, it's a little subtler than that, but think of it as the mechanical damping coefficient. And once again, if you plot materials according to those parameters, they spread out in a kind of band like this. And sure enough, up here, at the very top, there is bronze, which is what bells are made of, and glass, and things like that. They're things that ring when you tap them, and in fact, they're used musically to make bells and gongs and things of that sort. And down here are the soft, cuddly things, that have a low pitch, and they're heavily damped, so that if you wanted to, say, soundproof this room, you could do it, or improve the acoustics of the room, you could do it by picking materials that lie down the bottom here. If you want to do the same in your home, cork is in here somewhere, there, I think. Put cork on the floor, and it absorbs sound and doesn't ring when you walk on it. So once again, you could do blind tests with people to see if that works, and again, it works well. Right, can we do any more? Then it gets a bit more difficult. What about taste? Well, there, the group in London, Mark Miodownik is the head of it, did a very interesting thing. They took a set of spoons, and they plated them with various metals to see if you could taste them. And indeed, anybody's put a bit of metal in their mouth knows that it actually does taste. If you put a piece of copper in your mouth, it has a taste. So they plated the spoons with a number of metals. I've only shown 6. They did 10. And they included silver and gold and copper and chromium and so on. You'll see them in a minute. And their hypothesis, in this occasion, was that it might correlate with the standard reduction potential, or the electrode potential, because your saliva is an electrolyte, and if you stick a conductor into it, then its ions are going to move in one direction or the other, either onto the thing you put into your mouth or away from it, and you'd think that that might cause a taste. Well, they then got 3 chefs, actually 3 chefs from leading London restaurants. So it's quite a nice little experiment because they also got a good meal out of it. And they got the chefs to make a range of dishes and then eat them with these spoons and then make a comment on what they felt the taste was like. The chefs were quite interested in it because high-end chefs, 2-star, 3 Michelin star chefs, like to put in front of their customers unique dishes, and if they say the only way to eat this dish properly is with a chromium spoon. So let's see if it works. Right. So chromium and gold, well, there they are on in the electrode potential thing, and they're actually rather far apart, although the general view on this blind testing from the chefs was that they were about the same, and they were the most pleasant to use. Zinc and copper, they were the most metallic and bitter, and they are there, and two more, silver and zinc, and they are, oops, sorry, they are, wherever the new ones appeared, silver and zinc down there. So not too good. The correlation is just not there. So that's one that doesn't work. It's the most obvious guess, certainly, that it would be electric potential, but it doesn't seem to be the right one. At the moment, there isn't a lot better to go on. It must have something to do with enzymes, but it's not clear what it is. And so there's a bit more room there for exploration. And here are some more mysteries. That's a picture of a Stradivarius, and the front is made of Sitka spruce, and the back is made of maple, and that's perfectly standard in making violins. Now, you can size this thing. In fact, you can scan it and use a C-scan and get all the dimensions, and you can reproduce it exactly. You can make another one which has got exactly the same dimensions, and you can put it together, and you can give it to a violin player who has played a Stradivarius and say, is it any good? And the answer is no, it's not. It's not nearly as good as my Stradivarius. Well, that, of course, has been something that a lot of people have looked at. Why? What was it about those early violins which was so wonderful? It could be that the wood came from a particular tree that had a particular quality to it, although they try to match that when they do these kind of tests. It could be that it's simply the age of the wood that makes it different. There are theories that it's the glue that holds the thing together that has something to do with it. But certainly, it is not yet understood. The acoustics, the relationship between material and sound is not well understood in that case. And here's another example. About 200 years ago, Theobald Boehm, a flautist and a bit of an obsessive, as far as I can make out, made flutes out of just about everything he could think of, including glass. Exactly how you make a glass flute and put all this keywork on, I'm not sure, but he did. And he tested these flutes, and he pronounced the one that he thought was the ultimate flute is a silver one. And that's what everybody uses today, unless you're James Galway, and then you've got a gold one. But otherwise, it's silver. Now, the funny thing about it is if you talk to acoustics people, they say the material shouldn't matter. The only thing that matters is the column of air and the smoothness of the surface. If the surface is rough, you've got a problem. But if the inner surface of the tube is smooth, it doesn't matter what it's made of. It's just a tube, and it confines a column of air. And indeed, organ pipes, which are also columns of air that vibrate, are not made of silver at all. They're made of zinc and lead. So why silver? Well, if you ask professional flute players who've tried other flutes, there are many wooden flutes around, because before silver, wood was the principal material. They say, no, silver's the one. Silver is better. And here, for me, is the biggest mystery of all. That is an electric guitar. My son's a guitar player. This is the body of it. It's about 1.5 inches thick. It's a huge slab of Honduras mahogany if you really want a top-end guitar. Well, why does it matter? It doesn't vibrate. It's not a sound box or anything like that. And yet, high-end electric guitars are made of Honduras mahogany, which is very difficult to get now. So people are trying other things. But the people who use these guitars say they're not as good. And indeed, I contacted the editor of Electric Guitars, a magazine, and asked him about it. And he's a guitar player himself. And he confirmed that mahogany is an electric guitar made of Honduras mahogany is better than one made of anything else. Well, there is really no obvious reason for that at all. I have no idea why that's the case, but guitar players insist that it is. And so there is some mysteries here. Part of it, I think, points to the fact that we've got some very sensitive measuring equipment in our labs, but it's not as sensitive either as instrument players or indeed as certain sportsmen. If you ask people about the feel of a tennis racket, and they distinguish two as having different feels, it's very hard to measure what that difference actually is. So, very interesting thing. There's some properties there that we can't really get right. Right, we're still on aesthetics, so let's move on. Associations. What does the product remind you of? Well, here are some possible associations. Wealth, military hardware, aerospace, plants, animals, children's toys. I'll show you examples of some of those, but here, first of all, is a product that has used or tried to suggest these associations for different contexts, for different reasons, and here's some. A Rolls-Royce oozes wealth, there's no doubt about that. The choice of materials on the inside is all designed to reinforce that feeling. Military hardware, well, Jeeps and things like Land Rovers make explicit use of forms and shapes that derive from military hardware. In fact, a Jeep was originally a piece of military hardware. Aerospace, you'll remember the old aerospace-shaped cars. Plants and animals. I don't think the designer of the Volkswagen ever thought of making a car that looked like an insect when they did it, but it's called a bug in at least 4 different languages. And so somehow it suggests that particular association to a very large number of people. And then finally, children's toys, which are appearing more and more in cars, actually, particularly in the instrument panel, where they make use of big, round, colored discs for the speedometer and that kind of thing. So that's what I mean by associations. Now, you might not altogether agree with the words I've used here, but in general, I think most people would say, yes, I see what you mean. It does have that kind of association. So associations are like that. People, generally speaking, agree, at least in principle, about what they are. Perceptions, however, are completely different. Here's perceptions. How does it make you feel? What do you think about it? Well, some people might think a product was playful, but others might think it was just plain silly. Some might think it was responsible, and others might think it was irresponsible because it uses a lot of gas or something like that. Some might think a product was endearing, and others might see it quite differently, reassuring or disconcerting, cool or just plain awful. So let's look at an example. There is a little pink and yellow Vespa. To some people, that might be seen as attractive and practical and urbane, a nice little thing to have. But other people, and I can think of several, would see it as, well, girly, childish, wouldn't be seen dead on anything like that. It's impossible. What they would prefer is something that looks more like that, mainly because it's masculine and it exudes freedom and the open road, all that kind of thing. But the person who liked the Vespa would perceive that in a completely different light, as being loud and dangerous and even threatening. I wouldn't see it in the same light at all. So quite different perceptions. Here's another one. Let me try this one on you. That is a solemn object. And here is a material that is used often to make such things, and the fittings are often made of bronze. And so walnut and bronze would seem like appropriate materials for something with a solemn and slightly sad purpose like that. But supposing I told you it was made out of recycled polystyrene yogurt pots, would you still feel the same about it? And generally speaking, I think people would respond that they didn't, that they now saw it much more as a bin, as a sort of package, rather than something that was delightful. So perception is a subtle thing. It's real, however, and it's a very important part of design. Now let's try to pull some of these bits together. We've got an awful lot of bits. Here is, I have to admit, a hypothetical redesign problem. Here are 5 products: a hairdryer, an iron, a shaver, a toaster, and a mixer. And the remit is to redesign them to appeal to a different consumer group. Well, the first one we want to make is something cuddlesome and attractive, something you'd like your children to have. So here we go. There is the Turbo Puff dryer and the Hiss iron and the Lollipop shaver and the Piggy toaster and the Jelly mixer. Now, how has the designer done that? Well, first of all, they've used rounded shapes, primary colors, and forms which are clearly derived from children's toys. These rounded shapes here, even the color scheme as well, the simplicity of many of the shapes derives directly from the sort of plastic toys that, the more appealing plastic toys that your children or family might have. So there, the materials in this case are, well, there is some metal, but they're largely made of plastic, or that would be how they were made. The associations are pretty obvious. They derive from children's toys. And the perception they would like to convey, the designer might like to convey here, is of something which is unthreatening and friendly and appealing and generally a bit of fun. Here's another redesign of the same products. Here is the M25 heavy-duty hairdryer, the bolt-action iron, and the stealth shaver, and the Junkers front-line toaster, and finally the Kalashnikov mixer. Well, there the choice of materials is, hypothetically I must say, is different. They're angular shapes, dark colors, metallic. The whole thing's metallic. The associations are quite clearly military equipment, and the perception that the designer might be trying to convey is that these are serious products. They're heavy-duty products. They're indestructible. They're the sort of thing which is going to last forever, and in fact, they're kind of the ultimate durable product. Well, that's a way of those are extreme cases. So I'm going to now show you a couple of real ones, real products, I mean, and ask those questions. What was the designer, what was the context? What were the materials chosen? Why did they choose them? What associations are they trying to create? And what perceptions did they hope to leave? Here's one. It's my desk lamp at home, as a matter of fact. The context, I think, that the designer had in mind here was the office. It looks like an office product, but how did he make it look, or she make it look like an office product? It's also designed for continuous use and for fairly heavy handling. So the materials are pressed steel, and it is powder coated with a polymer powder coating with a slight texture to it. So the aesthetics are cream color, that's the color, the visual bit, sculpted shape, there's a slight texture. These are all things you can feel and touch and measure by those methods that I've been talking about before. The associations, if you look at the profile here, it's pretty much, and there, it's pretty much the same shape as a computer keyboard, and that's the idea, I think. The thing is supposed to sit on a desk near a computer and other such equipment and blend right in with it so that it is unobtrusive. So the color and the form are very like computer keyboards, and the perception then is one of subdued efficiency, something modern, efficiency, rugged, and fit for purpose. But if you were a mother looking for a lamp to put in your daughter's bedroom, you would see it in a different way. You'd see it as dull and impersonal and suggesting the office, and not at all the sort of thing that you'd want to have in that context. So the context really matters a lot. And once you're given the context, a lot of this then follows directly from it. Here is another lamp. It has almost the same specification. Actually, it's not quite as powerful as this one, but basically it's the same sort of thing. It's a desk lamp. And the context here is probably children's bedrooms, and the use would be intermittent. The material is quite different. They've achieved this form with injection molded acrylic. It's actually acrylic. And the aesthetics, well, pastel colors, smooth curves, and it's translucent, so when the light is on, this bit glows because some light comes through. That's all aesthetics. Associations, well, the forms are clearly derived, I was going to say from nature, but it goes beyond that. They're derived from cartoons of natural creatures and comic strips and things like that. Most people, I think, would have no difficulty in agreeing about that. And the perception, well, the perception they were aiming for is funny, playful, sort of a clever, cheerful thing. But to some people, it would seem eccentric. In fact, if your CEO at your company had one of those on his desk, you'd begin to ask whether something had gone wrong somewhere. So eccentric, frivolous, and silly. So So you can see how these perceptions really do differ and how important they are. I'm going to give you another example. Here's the product you saw earlier on. The context there is probably a contemporary living room, or even a boardroom somewhere modern and high-tech. Materials, these are made of brushed meaning slightly textured surface aluminum, and with black enamel. And the aesthetics are quite interesting. They make heavy use of primitives. Primitives are circles, cylinders, cubes, simple shapes like that. And indeed, it has got exactly that. It's got a tubular shape. It's got these square or circular bases. And the most telling thing of all, which gives the association, is the tapering at the bottom, which makes these things look like organ pipes. Well, what's the association of an organ pipe? Well, it's music, it's the arts, it's culture. So that there's all sorts of associations that are pulled out just by that one little bit of shape. Perceptions, well, high-tech, advanced, sophisticated, a symbol of discerning taste, something designed for people for whom only the best is good enough, that sort of thing. Well, that's true, but to some people, it would be a bit over the top. Design with a capital D, I put at the bottom there, overstated, and indeed that is some people's reaction to products like that, that the design has simply gone too far. It's become over-designed. So there are two quite different perceptions about a single product which has otherwise everything, it has the same associations. So let's look at a different radio, a little bit of electronics. These may look a little dated, and indeed they are. My mother had a radio that looked like that, but of course the inside isn't the same. These are now quite high-tech products. The context perhaps is to appeal to people in that age generation, so older people, and certainly not high-tech living rooms, but perhaps bedrooms or something like that. And the materials have been chosen with that in mind. Wood and leather and suede, that kind of thing. And the aesthetics, well, soft shapes and materials and muted colors. The associations, I think the idea is that of handcrafted products. The early ones were made by hand. And it's unashamedly retro. It's a retro design. And to remind you of the past. The good things about the past, of course. Well, the perceptions, old-style craftsmanship and durable and reassuring and non-technical and all the things that much electronics is not. That is to say, something that you just press the button and it works, and that's all you have to do. But to other people, it would appear mumsy. It's a bit like a handbag. And would you really want to go around carrying a radio that looked like that? So once again, the perceptions are quite different, even though everything else is the same. Well, here's a little case study that we give our students, and that I'm showing it because some of you here might be interested in that. That is a little compressor. It's got a light. It's got something to pump your tires up with. It's got two lights, as a matter of fact, and so it's quite an elaborate little gadget, but it costs £10, about $14. And that immediately suggests that it's some cheap thing that isn't going to last 5 minutes. So what has the industrial designer done about that? They've been given the task of designing the appearance of a product which is very cheap, but they don't want to suggest that, because then people won't buy it. All right, so let's have a look. What are the aesthetics? What are the associations, and what perceptions do they breed? And finally, what's the designer trying to say about the product? Well, let's have a look at some other products. That's not a very good picture of a case that designed to carry machine tools around in, drills and portable saws and things like that. And it's made out of ABS. It's got virtually no color to it, and it's got a very simple shape. These are parallel lines. They don't look it, but because of the perspective. But it's got horizontals and verticals. It's got texture which is either matte or shiny, but no colors. It's just the same material in two different kind of textures. And it's got repeated horizontals on it. Here's another such product, power drill. And the same thing applies there. Repeated parallels, the only decoration is sets of closely spaced parallel lines. Here's another one, another industrial strength product. And once again, it's got these many horizontal parallels. And where there are verticals, they tend to converge upwards, as these ones here do. There's upward converging diagonals. Here's another one. Same story again. Repeated horizontals, and where there are verticals, they tend to converge upwards like that. And then there are numerous repeated parallel lines that are, again, vertical or horizontal. So this repetition of horizontals and verticals, lack of color, I'll list them. Here they are. Angular straight-edge forms, repeated horizontals, and upward converging diagonals, and subdued color, if there's any at all, as here. Use of texture to create contrast, and minimal decoration. Those are things that characterize these products, and most people would see these as industrial strength products, something that is fit for purpose and is going to last. Well, that's exactly what they're trying to convey, I think. Here we have it, the horizontals, the upwardly merging diagonals. There they are again. The repeated parallels, either horizontals or verticals, and the subdued color, the same sort of thing, with the contrast between the polished and the textured part here. So they've derived all of those features from other products that have a certain character to them. So if I listed them, those are exactly the words, I won't read them, that I used on the previous slide. They're exactly the same thing. So if we're asked then, what is the designer trying to say? And I think the answer is that all that adds up to a message that this is not a toy. This is something really serious. It's a good little compressor, and if you buy it, it'll last you for as long as you want it to last. So that's the story there. That's quite useful. We try to get students to think that through first for themselves and see how many associations they can themselves find, and give them a little help on the way to see just how far they can analyze a product. Now, that is my final message, I think. I'm going to just summarize it in two overheads. It's interesting. In fact, it makes quite a stimulating activity to try to analyze products when you see them in stores. And one way of doing it is, first of all, to see it as a whole. Think of it in more than one way. What does the product do? Who will use it? The context? What do you think their aspirations are? What other things have they got? How does that affect functionality, usability, and satisfaction? Bearing in mind that this element of satisfaction today is really important in selling products. If you don't provide satisfaction, some other manufacturer will, and the product you're making is not going to sell, no matter how good it is. So the idea here is to train yourself to look at products and ask, what are the aesthetics, what color, what texture, what other aspects of things you can touch, what associations, how did the designer create those associations, and why do you think they did? And finally, what perceptions? How did the product make you feel? And it may be that you like it, but it may also be that you don't. And if you don't, it's very interesting to ask how the designer has unintentionally created that reaction in you, because they clearly wanted it to appeal. And if it doesn't, then there's something about you're perceiving it in a way that the designer did not anticipate. So the final question of all then is, what was the designer trying to say? And at that point, I'll stop. Thank you.